All right, so here's how today's going to work. You're going to do the warm-up on your own, all right? And then we're going to go through a variety of examples from the interim test that are a little bit different. And I'm going to give you an example, and then you're going to try it on your own. And then I'm going to give you the answer. And then I'm going to give you another example, try it on your own, give you an answer. And then that should not take you very long, okay? This whole thing should not take us very long. And then you're going to get a exit ticket from the guest teacher, and you need to finish that, and that all has to be completed before you are allowed to leave today. So, do the warm-up real quick on your paper. Okay, so your answer to everything should be 1, because anything to the power of 0 is 1. Okay, if you're trying to figure out, okay, how can I get 5 to something to equal 1? Well, 5 to the 0 is 1. Anything to the 0 power is 1. Please, please, please remember that. All right, so the first problem, let's start with our objective. We're going to be able to apply our knowledge of exponent rules to a variety of different problems. So the first problem we are going to deal with looks like this. So there are 2 ways you can go about doing this. You can either distribute first, okay, and multiply, or we can solve the inside first, which I think will be easier. So I'm going to take this, because they have the same base, and I'm multiplying them, I'm adding my exponents. So -4 plus 3 equals -1. So inside the parentheses, I have 3 to the first power and outside cubed. Okay? When I have a power of a power, I multiply. So this becomes 3 cubed, which simplifies to 27. Okay, your turn. Pause the video, try it, check your answer. All right, so you should be back from pausing the video, and now you're checking your answer with me. So you should have added and gotten 4 to the first power, to the 5th, 4 to the 5th, and then you should have gotten the answer, which I don't really care that much about. But as long as you got this, that's what matters. All right, next one. An equation is shown below. What value of k makes this equation true? So the biggest thing that it says here is an equation. So that tells you right there that you probably need to be writing an equation to solve this. So the first thing I would do, if this was a number instead of k, if it was like 2, I would solve the top by by keeping the base and adding my exponents. Well, my exponent's a 1 here, so I would get 6 to the 1 plus k, keeping the base, adding the exponents. Okay, over 6 to the -10 equals 6 to the 8. From there, I would subtract. Okay, so I would keep my base. 6 is still going to be my base. And I'm going to take my exponents, 1 plus k minus -10. 1 plus k minus -10. Well, if I add the opposite, that becomes 1 plus k plus 10. And I know that has to equal 6 to the 8. So what that tells me is that this, whatever this is here, has to equal 8. So I can rewrite this as an equation. 1 plus k plus 10 equals 8. Well, 1 plus k is 11. So k plus 11 equals 8. Subtract 11 from both sides. K equals -3. So that is my answer. All right, if you try this one on your own. All right, so you should have gotten k equals negative 10. All right, because k plus 1 minus negative 13 needs to equal 4. K plus 14 equals 4. When I subtract 14 from both sides, k equals negative 10. All right, next, evaluate the following. This one is fairly simple. We start with multiplying, so we add our exponents. So 4 to the 9 over 4 to the 8. Then when I have dividing, I subtract. So this becomes 4 to the first power. Pause the video, try this one on your own. Okay, this one might become a little bit more tricky because, and you should be back from trying this on your own, that we have 7 to the 8 over 7 to the 10, which means that 8 minus 10 is negative 2, so we have 7 to the negative 2, which means I need to simplify that to 1 over 7 squared, which is 1 over 49. Okay, another way to think about this, guys, if you're really struggling with the negatives, draw a fraction line, okay, and look, which is bigger, 8 or 10? Well, 10 is bigger. 10's on the bottom, so my 7's going to end up on the bottom no matter what. 10 minus 8 is 2. When I have nothing up here, I have a 1. Okay, get the same answer that way. All right, this one becomes a little bit more tricky, but not really. There's just 3 things that we need to be doing. Okay, so I'm going to simplify the top and the bottom first. 4 to the 6 is going to stay the same. 5 squared times 5 to the 5th is 5 to the 7th. Over 4 squared is the same. 5 times 5 to the 3rd is 5 to the 4th. Okay, then I subtract my exponents. So this becomes 4 to the 4th times 5 cubed. And you could simplify this out if you needed to or if you wanted to. I'm fine. Well, I would like you actually to simplify this out. So 4 times 4 times 4 is 256 times 125 is 32,000. All right, that one should have been easy, so I'm not going to have you do another one like that. All right, what are 3 ways we could write the following? Okay, so this one might actually will. All right, so the first thing I need to do is parentheses. Well, there's nothing inside the parentheses that I can do. So next, I need to do my exponents. I'm using order of operations. So I'm going to multiply. Okay, this 2 is only on this 6 to the negative 2. It is not on the entire expression. So I'm going to rewrite 6 squared times, when I multiply, I get 6 to the negative 4. Okay, so when I add them, I get 6 to the negative 2. That's one way to write this expression. Okay, that also equals 1 over 6 squared. That's a second way to write this expression. And the last way to write it is 1 over 36. So there are 3 ways to write a negative expression. Okay, I want you to try this one on your own. So, you should have written 4 to the negative 1, which equals 1 over 4. And really, there's actually only 2 ways that you could write this expression. All right, the last one we're going to do is an order of operation problem with negative exponents. So 3 plus 3 squared is 9 times 6 to the negative 2 is 1 over 36. If you're not seeing this and automatically knowing that by now, we have a problem. Figure it out. Plus 1/2. All right, my 9 and 36, when I multiply, because that's my next step, can cancel. Okay, 9 becomes 1, 36 becomes 4. So this becomes 3 plus 1/4 plus 1/2. All right, I add 3 plus 1/4 to get 3 and 1/4 plus 1/2. I need to find a common denominator, so this becomes 3 and 1/4 plus 2/4, which equals 3 and 3/4 as my final answer. Okay, try this last one on your own. All right, welcome back. You should have said 7 plus 64 times 1 over 16 plus 2/3. All right, well, 64 divided by 16 is 4, so 7 plus 4 plus 2/3. 7 plus 4 is 11, plus 2/3 is 11 and 2/3. All right, so you need to go to the guest teacher and pick up your exit ticket with, I think, 6 or 7 questions on it, and you need to complete that before you can leave. I need that in my hands on Monday. So that means I need it before school Monday, so you need to finish it now.